back to factoring quadratic trinomials where the leading coefficient a is not equal to 1. We're going to have today and we're going to have Thursday, and then I'm going to assign a test. So there will be a test due Friday at 11:59 p.m. So today and Thursday, and then a test. All right, so first things first, what should my strategy be? Well, I know that A is 12, B is 36, and C is 27. So whatever 12 times 27 is, I'm going to figure out what combination multiplies to that and adds to 36. But you know what will make my life easier is if I can factor out the GCF in advance. Is there a number that I can factor out of 12, 36, and 27 right now? In fact, there is 3, because 3 goes into 12, 36, and 27, and that's the biggest number that goes in there. 4 can't go into 27, 6 now. So it has to be 3. So if I factor out the 3, my new trinomial in the middle becomes 3 times what is 12x squared? 4x. 3 times what is 36x? Positive 12x. I was going to put a 9. I was like, oh man, that could have ended badly. 3 times 9 is 27. I was looking at the 27, so I apologize. Anyway, so we've got 3 factored out, and now my quadratic trinomial has A equals 4, B equals 12, and C equals 9. So that, even though it's, sorry, that's an x squared. Even though the problem still requires a little bit of thought, it's a lot better than figuring out what multiplies to 12 times 27. Because now my A is 4 and my C is 9, so my AC is positive 36, and my B is positive 12. So what's the combination? Positive, positive, negative, negative, or 1 positive, 1 negative? It has to be 1 positive, 1 negative. It has to be 1 positive and another positive as well, so both positives. So let's list out the factors. 1 and 36. 1 times 36 is 36. 1 plus 36 is 37, so that doesn't work. 2. 2 times 18. 2 times 18 is 36. 2 plus 18 is 20. 3. 3 goes into 36 12 times. 3 times 12 is 36. 3 plus 12 is 15. 4. 4 times what is 36? That would be 9. 4 times 9 is 36. 4 plus 9 is 13. 5 does not go in there because it'll be a decimal. 6. 6 times 6, rather. 6 times 6 is 36. 6 plus 6 is 12. We have a winner. So what's so special about this winning combination, this positive 6, positive 6? Well, in the next step, the middle term gets split. So instead of 4x squared plus 12x plus 9, I can split this now into positive 6x, positive 6x. So I've got 4x squared plus 6x plus 6x plus 9. Okay, so now I'm going to factor by rectangle. So I'm going to put all 4 terms in their appropriate spots of the rectangle. So the big fella gets ax squared, or in this case, 4x squared. The bottom right gets positive 9. And it doesn't matter, it really doesn't matter in this case where the split bx's go. So I'm going to put positive 6x and positive 6x. I'm going to cover up the right column. Can I factor anything out of 4x squared and positive 6x? What number can I divide out of both of those? Well, the GCF of 4 and 6 is 2. X squared and x have an x in common, so the GCF of 4x squared and positive 6x is 2x. And now I'm going to expose the remaining 3 terms, and the rest of the problem is going to fall like a set of dominoes. Now, 2x times what is 4x squared? 2x. 2x times what is positive 6x? Positive 3. 2x times what is positive 6x? Yet again, positive 3. Check your work. Positive 3 times positive 3 is positive 9. Therefore, the correct factored form of this problem, don't forget what we factored out in advance. We factored out a 3. So the correct factored form of this problem is 3 times 2x plus 3 times 2x plus 3. Yet again. Sorry about that ink. There we go, much better. Yeah, 3 times 2x plus 3 times 2x plus 3, or 2x plus 3 gets squared. But don't forget about the factored out 3 in front, or you will not get full credit. Okay. Show this really quick. Okay. All right, number 2. 36x squared minus 30x plus 4. Well, I suppose I could make A 36 and C 4, but that seems like a big number. So could I factor in advance? Yes. All 3 can factor out a 2. 2 times what is 36x squared? 18x squared. 2 times what is negative 30x? Negative 15x. 2 times what is positive 4? Positive 2. Now my ABC seems a little bit easier to deal with. A is 18, B is negative 15, and C is positive 2. So let's figure out what 2 numbers multiply to AC and add to B. In this case, my A is 18 and my C is 2, so that AC needs to be positive 36, and my B is negative 15. So what 2 numbers multiply to a positive and add to a negative? Well, it has to be a negative-negative combination. So specifically, negative 1, negative 36. Negative 1 times negative 36 multiply to positive 36, but they add to negative 37. Let's try 2. Specifically, negative 2 and negative 18. Negative 2 times negative 18 is positive 36. Negative 2 plus negative 18 is negative 20. All right. Negative 3 goes in there. Yeah, negative 3 and negative 12. They multiply to positive 36, but they add to, hey, negative 15. We have a winner. So what's so great about this winning team? Well, now this splits the middle term. So specifically, we don't have 18x squared minus 15x plus 2 anymore. I can split this equation into 18x squared minus 3x minus 12x plus 2. So now I put all 4 of those terms in the appropriate spots of the rectangle. Well, the top left is the big fella, so I'm going to put 18x squared there. And on the bottom right, positive 2. It doesn't matter which of the 2 split middle terms go where, so I'm going to put negative 3x here and negative 12x over there. It doesn't matter. So specifically, I'm going to cover up this column. What 2 numbers, what can I factor out of 18x squared and negative 3x? And let's keep the factored out positive. Specifically, I can divide 18 and 3 by 3 and x squared and x by x. So the GCF is 3x. 3x times what is 18x squared? So that'd be 6x. 3x times what is negative 3x? Negative 1. 6x times what is negative 12x? Negative 2. Check your work. Is negative 2 times negative 1 positive 2? All right. So now the final solution is, did I factor anything out in front? Yes, I factored out that 2. So don't forget about what you factored out in advance. So the final answer is 2 times 6x minus 1 times 3x minus 2. So So that breaks down the quadratic trinomial into a multiplication problem. A big, helpful tool for Algebra 2. Okay, now that we got that part of the way, let's move on to problem number 3. 2x squared plus 3x minus 20. First things first, can I factor anything out from 2, 3, and 20? Well, nothing besides 1, so I have no choice but to make this a equals 2, b equals 3, and c equals negative 20. There's nothing I can factor out in advance, but luckily the numbers aren't too big, so I'm pretty happy. So I need to figure out what multiplies to AC. In this case, my A is positive, my C is negative, specifically 2 times negative 20, so that'd be AC is negative 40. And my B is positive 3. Two numbers that multiply to negative 40 and add to positive 3. Well, if it multiplies to a negative, it has to be 1 positive, 1 negative. But that positive 3 tells me that the positive number has to be way stronger than the negative. So let's get going. So let's make a table with weak negatives and strong positives. Negative 1 and 40. Okay, well, they add up to positive 39. Negative 2 and positive 20. Well, they multiply to negative 40, but they add to 18. Not very helpful. 3 does not go in there unless it's a decimal, so let's go with negative 4 and 10. Negative 4 times 10 is negative 40. Negative 4 plus 10 is 6. All right, let's go with 5. Specifically negative 5 and positive 8. Negative 5 plus 8, though, is positive 3. Ah, we won. Check. There's my winning team. So what's so special about this winning team? Well, now that this 2x squared plus 3x minus 20 is the way it is, I'm going to split the middle term into negative 5x and positive 8x. So I make my 4 terms, and I'm going to make that rectangle. Specifically, the big fella is positive 2x squared, and the bottom right corner is negative 20. And it doesn't matter which one is which. Just out of force of habit, I put the left one down here and the right one up there. So I'm going to cover up the right column. Can I factor anything out from 2 and 5? Well, nothing really besides 1, but x squared and x can factor out an x. So technically the GCF of 2x squared and negative 5x, I can factor out an x from both of them. Now, imagine there's a 1x in there, if that makes your life a little bit easier. Let's figure out the other pieces. X times what is 2x squared? That'd be 2x. 2x times x is 2x squared. And now, x times what is negative 5x? Negative 5. 2x times what is positive 8x? So now, 2x minus 5, x plus 4, so that's how you factor it out. So 2x minus 5 times x plus 4, and that's how you factor this quadratic trinomial. All right. Number 4. 6x squared minus 9x minus 15. See if you can do this problem independently by using the pause button. Okay. Well, first things first. What should I do? Well, all 3 of those terms can factor out a GCF, specifically 3. So I factor out the 3, and I'm left with a new quadratic trinomial in the middle that's going to make my life easier. So 3 times 2x squared is 6x squared. 3 times negative 3x makes negative 9x. And 3 times negative 5 becomes negative 15. Ah, much better, significantly better, because now my A is 2, my B is negative 3, and my C is negative 5. Much smaller numbers, much easier to digest. So my a is 2 and my c is negative 5, so my AC is negative 10, and my b is negative 3. Two numbers that multiply to make a negative means it has to be one positive, one negative. But if I say it adds to negative 3, what does that tell me about the one positive, one negative combination? The negative has to be stronger than the positive. So let's make a table with weak positives and strong negatives. 1 times negative 10 is negative 10. 1 plus negative 10 is negative 9. That didn't work. Let's try 2. 2 times negative 5 is negative 10. 2 plus negative 5 is negative 3. We have a winner. So that checks out. So now that we figured out this winning combination, we can split the middle term. 2x squared minus 3x minus 5 now becomes 2x squared plus 2x minus 5x minus 5. Now I'm going to put all 4 pieces into the rectangle. So let's do that. So I've got 2x squared, negative 5. So 2x squared goes in the top left. Bottom right becomes negative 5. Doesn't matter which one's which, so I'm going to plug in positive 2x here and negative 5x over there. I'm going to cover up the right column. What can I factor out of 2x squared and positive 2x? Specifically, I can factor out a positive 2x. Sorry about something. I have something wrong with the computer. Okay. So specifically, I've got positive 2x factored out. 2x times what is 2x squared? Well, 1x. So 2 times 1 is 2. X times x is 2x is x squared. So that's 2x squared. 2x times what is positive 2x? Positive 1. X times what is negative 5x? Negative 5. Check your work. Is negative 5 times positive 1 negative 5? Yes. Did I factor anything out in advance? Don't forget, I factored out the 3 in advance. So if I factor out the 3, I'm left with 3 times x plus 1 times 2x minus 5. And that is the final factored form for problem number 4. Okay. All right, moving on to the last 2 problems of the day. Problem number 5, 3x squared minus 7x minus 10. Can I factor something from all 3 of these terms? All right, I'm going to get you started, and then we're going to do this, and then you're going to do this problem independently. So I can't factor anything out, but a is 3, b is negative 7, c is negative 10. Figure out what 2 numbers multiply to the AC, negative 30, and add to b, which is negative 7. Pause the screen and do this problem independently. Okay, so now that you've done this problem independently, how do we figure out what 2 numbers multiply negative 30 and add to negative 7? It has to be a positive times a negative combination with the stronger negative. So let's make a table with weak positives and strong negatives. 1, negative 30. 1 times negative 30 is negative 30. 1 plus negative 30 is negative 29. Well, that didn't work. 2 and negative 15. 2 times negative 15 is negative 30. 2 plus negative 15 is negative 13. Okay, not there yet. Let's try 3. 3 and negative 10. 3 times negative 10 is negative 30. 3 plus negative 10 is negative 7. There we go. We've got a winner. And what's so special about this combination? I'm going to split the middle term. So instead of 3x squared minus 7x minus 10, I'm going to split this middle term into positive 3x and negative 10x. So now I put the ax squared and the c in the corners, and it doesn't matter where the bx's go. So now I've got, I'm going to put positive 3x here and negative 10x there, and I'm going to factor out the GCF. What happens if I try to fake out, not fake myself out. I fake myself out talking about faking myself out. What's the GCF of 3x squared and positive 3x? Well, I can both factor out a 3 and an x, because 3x squared and 3 and 3 share a factor of 3 in common, of course. X squared and x share an x to factor out. 3x times what is 3x squared? That'd be an x. 3x times what is positive 3x? Positive 1. X times what is negative 10x? Negative 10. Check your work. Is positive 1 times negative 10 negative 10? There you go. Once again, did I factor anything out ahead of time? No, I did not. So to break this down into a multiplication problem, the final answer is x plus 1 times 3x minus 10. And again, you could have done this 3x minus 10 times x plus 1. It does not matter. All right, last problem of the day. Once again, we'll have a final review session on Thursday and then a test on factoring quadratic trinomials on Friday. So we've got 10x squared plus 5x minus 140. Oh, good heavens. Okay, so my a is 10, my b is 5, and my c is negative 140, unless I can factor something out ahead of time, which I'm hoping I can. What can I factor out of all three of these terms? Well, I wanted to factor out the 10. That'd be awesome, but 5x cannot be divisible by 10. But luckily, all three of these can be divisible by 5. So now I've got 5, 2x squared plus 1x, and negative 140 divided by positive 5 is negative 28. So now my new ABC, easy as 1, 2, 3, don't sue me for copyright. A is 2, B is 1, and my C is negative 28. Okay, so now my AC is positive 2 times negative 28, or negative 56. And my B is positive 1. Well, what does that tell me about this combination? Well, in order to multiply to negative 56, it has to be a positive-negative combination. But that positive 1 tells me that the positive is a little bit stronger than the negative. So let's make a table. So we've got weak negatives and strong positives. Negative 1 and 56, they multiply to negative 56, but they add to 55. Negative 2 and positive 28, they multiply to negative 56, but they add to 26. 3 goes into 60, go back, this would be 57, go back, would be 54. So no, 56 divided by 3 would be a decimal. Let's try negative 4. Well, 4 goes into 60 15 times, so 56 would have to be 14 times. So negative 4 times 14 would be negative 56. Negative 4 plus 14 would be positive 10. Closer and closer to 1 we go. 56 divided by 5 is a decimal, because it does not end in a 5 or a 0. But let's see, doesn't divisible by 6 either. If it's not divisible by 2 and 3, it's not divisible by 6. But 7, yes. Negative 7, positive 8. They multiply to negative 56, but they add to positive 1. So that checks out. Now then, what's so special about this? Well, that winning team is going to factor out into negative 7x, positive 8x. So now I've got 2x squared minus 7x plus 8x minus 28. Now I'm going to put all four of these into the rectangle. So I've got the big fella, 2x squared in the top left, negative 28 in the bottom right, and now let's put in negative 7x and positive 8x. I'm going to cover up the right column. Can I factor anything out from 2 and 7? Well, no, nothing besides 1, but luckily x squared and x can factor out an x. So the GCF would be 1x. You can put a 1 there if that makes your life easier. X times what is 2x squared? 2x. X times what is negative 7x? Negative 7. 2x times what is positive 8x? Positive 4. Check your work. Is negative 7 times positive 4 negative 28? Yes. Did I factor ahead of time? Yes, I factored out a 5. So the final answer is, if I factor out a 5 times the quantity of 2x minus 7, this factored out part right here, times the factored out part of x plus 4. So that's how you make a multiplication problem out of this quadratic trinomial. Okay, one more review day and a test will be on Friday.